The next identities that we're going to be looking at are the double angle identities. So we have 1 for sine, we have 3 for cosine, we have 1 for tangent, and then we have some variations as well. So for the 1 for sine, we have sine of 2 theta is equal to 2 sine of theta cosine of theta. Well, if that were sine of 4 theta, then that would be 2 sine of 2 theta cosine of 2 theta. So whatever the angle is, you're really cutting that in half here and here. So if this were sine of 6 theta, it would be sine of 3 theta cosine of 3 theta with a 2 out in front. And if this were sine of 8 theta, it's 2 sine of 4 theta cosine of 4 theta. So sometimes in calculus, having only sine or only cosine makes a problem easier. So you'll have calculus techniques and you have multiple ways to solve problems, but if you have a certain problem and you can express it using only sine or sometimes only cosine, then you can make your life easier. So that's why we're kind of doing these questions. So it says, use a double angle identity to rewrite in terms of only sine. So one more thing I kind of want to talk about here is the coefficient that's on the outside. So like this 2 here basically becomes a 1 here. So another way of looking at this is that we are taking half of the outside coefficient and we are taking double the inside coefficient. So this would be 1 sine of 6x. So take half of this and double of these. But we don't really need to put the 1, it's just sine of 6x. So I've expressed this now only using sine. I no longer have a sine and a cosine. For number 5, I'm going to do the same thing. I'm going to take half of the outside coefficient. So instead of 10, it's going to be 5. And it's sine of double the inside coefficient. So 14 theta. So I'm really using these that identity and then the variations of it. An alternate way to do number 5 would be like if you wanted to show it as so an alternate way would be if you call it 5 times 2 sine of 7 theta cosine of 7 theta, then you can just use the identity on the inside to give you sine of 14 theta and then bring the 5 down. So that's kind of another way to do it, and it makes it look more like the identities. But the other way is to just say half of the outside coefficient and double the inside coefficient. So on number 6, half of the outside coefficient would be 7 over 2, and then that merges to be sine of double the inside coefficient, or 10y. So again, the purpose of these is we are trying to express it in terms of only sine. Okay, number 7 says use a double angle identity to rewrite in terms of only cosine. And this one really looks like this one here. And in the identity itself, it's theta on the right and 2 theta on the left. So we have 4x. So when we merge it, it's going to be 8x because it's double what that coefficient is. So now this is in terms of only cosine. So if you have to take calculus, using these identities is really helpful on many different problems.